Hi, welcome to class. My name is Don Lafont, Professor Don, and in this presentation, we cover Module 13, Wireless LAN Configuration. This is Cisco 2, and just a moment ago, we covered Module 12, Wireless LAN Concepts. Make sure you review Module 12 before you review Module 13, because otherwise it'll be difficult for you to understand some of the concepts. All right, let me go ahead and share my screen. If you have any questions and you're here with me live, please hold those questions until the end of the presentation, and I will give you a period of time to ask questions. If you're watching this as a recording inside of my NetAcad class, ask your questions inside of the help discussion forums. And if you are watching this on YouTube, please ask questions in the comment section below the videos, and I'll be sure to take a look. But also feel free to answer each other's questions as well. Okay, Module 13. In this module, we are going to implement a wireless LAN using a wireless router and wireless LAN controller. We'll configure a wireless LAN to support a remote site. We'll configure a wireless LAN controller, wireless LAN to use the management interface and WPA2 PSK authentication. We'll configure a wireless LAN controller, wireless LAN to use a VLAN interface, a DHCP server, and WPA2 enterprise authentication, and we'll troubleshoot common wireless configuration issues. So a remote site wireless LAN configuration. I have a video to get us started out in this. This is 13.1.1. And this will help you to understand the concepts.
Hello everyone, it's time to get our computer hooked up to a network. In this video, we're going to do a wired and wireless configuration using our Cisco wireless router. To start, we will connect our computer's Ethernet port using a network cable to one of our LAN ports on the back. Take my computer's Ethernet cable and plug it into one of our LAN ports. Next, we want to get this wireless router connected to the internet. So I'll take my internet cable from my modem and plug that into my WLAN port on the back. At this time, I can go to my computer's web browser and I can type in the IP address of my Cisco wireless router. If you do not know the default IP address of your wireless router, you can look it up in the documentation that came with it. Or you can use some command line tools on your user device. My wireless router has the default IP address of 192.168.1.1. I'll type it.
Okay, I'm going to stop the video here because I showed the same video inside of the Module 12 presentation. It's repeated here. So if you haven't seen this video, please watch the Module 12 video, and you will it will help you to understand the concepts for this module. One second. Yeah. I'm basically, it just shows you connecting the ports into the back of the router and then going in and configuring basic configurations for your router. Again, I showed you that same video inside of Module 12 presentation. I must have felt it was important to understand the concepts there. And you can also see that inside of our classroom. So if you're watching this as a recording and you want to go see it, just hit pause and go watch it. If you're here with me now, you just saw that video, so there's no need for me to play it again. Now, the wireless router, remote workers, small branch offices, and home networks often use a small office and home router. These integrated routers typically include a switch for wired clients, a port for internet connection, sometimes labeled a WAN, and wireless components for wireless client access, such as through a laptop or a tablet or your cell phone. These wireless routers typically provide wireless LAN security, DHCP services, integrated name address translation, NAT, quality of service, QoS, and as well as a variety of other features. The feature set will vary based on the router model. Note, cable and DSL modem configuration is usually done by the service provider's representative on one side or remotely. Sometimes they'll come out to your house and configure it in person. Sometimes they configure it over the phone. Sometimes they have automatic settings so that they're configured automatically. I'll go with that. Log into the wireless router. Most wireless routers are pre-configured to be connected to the network and provide services. Wireless router default IP addresses, usernames, and passwords can easily be found on the internet. Therefore, the first thing you should do is to change the defaults for security reasons. To gain access to the wireless router's configuration GUI, open a web browser and enter the default IP address of your wireless router. The default IP address also can be found in the documentation that came with the wireless router, or you can search the internet to find, just put in the brand that you have and it'll tell you what the IP address is. The word admin is commonly used as the default username and password. Basic network setup. So basic network setup includes the following steps: logging into the router from a web browser, changing the default administration password, logging in with that new administration password, changing the default DHCP IPv4 address, renewing the IP address, logging into the router with the new IP address. Basic wireless setup include viewing the wireless LAN defaults, changing the network mode, identifying which 802.11 standard to implement, configuring SSID, configuring the channel, ensuring there are no overlapping channels to use, configure the security mode, whether you want open, WPA, WPA2, personal, WPA2 enterprise, etc., and configuring the passphrase as required for the security mode that you've selected. Now, in small office or home networks, one wireless router may suffice to provide wireless access to all of the clients in the home. If you want to extend the range beyond approximately 45 meters or 90 meters outdoor, you can create a wireless mesh. Create the mesh by adding access points with the same settings, except use different channels to prevent interference. Extend the wireless LAN in a small office or home office has become increasingly easier. Manufacturers have made creating a wireless mesh network, WMN, simple through smartphone apps. And remember earlier we talked about the different channels. Channel 1, 6, and 11 are do not overlap, and so here they've implemented 2, and they've those 2 channels they're using is 1 and 11. They are 1 and 11. Now NAT for IPv4. Typically, remember network address translation for assigning public addresses, using one public address for multiple private addressing. Typically, the wireless router is assigned a publicly routable address by the ISP and uses a private network address for addressing on the LAN. To allow hosts on the LAN to communicate with the outside world, the router will use a process called network address translation, NAT. NAT translates a private local source IP address to a public global address. The process is reversed for incoming packets. NAT makes sharing one public IP address possible by tracking the source port numbers for every session established by a device. If your ISP has IPv6 enabled, you will see a unique global unicast, a GUA address, global unicast address, IP6 address for each device. You guys should be familiar with NAT. We've worked with NAT already. Quality of service. Many wireless routers have an option for configuring quality of service, QoS. By configuring QoS, you guarantee a certain traffic type, such as voice and video, are prioritized over traffic that is not as time sensitive, such as email and web browsing. On some wireless routers, traffic can be prioritized on specific ports. And here they show the configuration steps for QoS. And they set them by IP phone is more important than, say, SMTP, email. Wireless routers typically block TCP and UDP ports to prevent unauthorized access in and out of a LAN. However, there are situations when specific ports must be opened so that a certain program and application can communicate with devices on different networks. Port forwarding is used to keep unwanted traffic off networks. It allows network administrators to use one IP address for all external communications on the network while dedicating multiple servers with different IPs and ports to the task internally. Port forwarding is a rule-based method of directing traffic between devices on separate networks. Port triggering allows the router to temporarily forward data through inbound ports to a specific device. You can use port triggering to forward data to a computer only when a designated port range is used to make an outbound request. You are going to do a packet tracer 13.1.10, where you are going to configure a network, a wireless network. Then you'll do a lab to do the same thing. Configuring a basic wireless LAN on a wireless LAN controller. Here's a video 13.2.1 to explain this concept.
Hello everyone, we are here to configure a basic wireless local area network on our Cisco wireless LAN controller. This is great. The Cisco wireless LAN controller, or WLC, is an amazing box that allows you to have a centralized location for configuring multiple access points and deploying multiple wireless local area networks. So let's take a look at our topology. We've got a Cisco wireless LAN controller off of switch 1. We have a trunk connection to carry multiple VLANs. Why would we want multiple VLANs between the switch and a wireless LAN controller? Because we're going to have one VLAN segmenting our management network. The management network is how we're going to configure the wireless LAN controller, as well as how we will communicate with our Cisco access points. Secondly, we need another network which is going to connect the user traffic from the access points to the wireless LAN controller. And this is the users on the network, their traffic. So we will see these trunk connections in between our switch and the wireless LAN controller, and then even switch into our access points to allow multiple networks to exist and be segmented on those cables. We then have router R1 over here on the left side, which also has a trunk connection, because router R1 is going to be doing inter-VLAN routing and routing between multiple VLANs, which are networks, between itself down to the rest of the topology. Also, if we take a close look, we'll see there's going to be a wireless client connected off of access point 1. Access point 1 has a link with PoE marked on it. That is power over Ethernet. Access point 1 is being powered by switch 1 itself on port FA01. We're going to get started here. We're going to be using PCB on VLAN 1, the management network, to communicate with the wireless LAN controller and to configure it using a GUI. Let's get started. Here on PCB, we've opened a web browser and we've targeted the 192.168.200.254, which is the management IP address of the wireless LAN controller. We are crossing the switch from PCB on VLAN 1 and connecting with this wireless LAN controller so we can configure it on the management network. Since we've accessed the control already on this web page, we're going to click Login and we'll be asked for credentials. With the credentials, we're going to have a username of admin, and then we're going to have a password of Cisco123 with a capital C. I'll click Sign In, and we'll successfully authenticate. And here's our main splash page on the Cisco wireless LAN controller. Right now, you can see that we have no wireless networks deployed. We've configured 0 wireless networks, so any access points that are joined with this controller, they have no wireless networks to share with users. We can see that one access point has joined, that is the Cisco access point of AP1 sitting on that topology screen. At this time, we have 0 active clients. Nobody has joined our wireless networks because we don't have any wireless networks. So let's make one. Let's create a basic wireless local area network. So to get started, I'm going to click on Advanced. We're jumping right in. When I click on Advanced, we're going to get an overview screen of my Cisco wireless LAN controller. Here it is. You can see that we have one port plugged in, just one. That one green physical port has multiple networks because of our VLANs. We have VLAN 1, which is for management, which we're using right now on this green port. And we have VLAN 5, which is going to be for user data traffic, also on this green port. That is done through what are called VLAN interfaces. VLAN 1 has its own VLAN interface, and VLAN 5 has its own VLAN interface. Top wireless local area networks. It's empty. We've got none right here. So let's get started and make one. I'll go ahead and click on wireless local area networks. Inside of here, there's none listed. So with a drop-down set of create new, we will click go, and let's make one. For the profile name, I'd like to name it something like wireless_LAN. And for the actual wireless SSID that the users will see, I want to keep it the same, wireless_LAN. The ID is for me to keep myself organized. I'll leave it at the original ID of 1. When I click apply, we are not done. We have just begun. After it loads, we will see here that we have many settings to choose from for our wireless_LAN profile. We can see this is a wireless local area network. The SSID of what the users will see. We should probably turn on this wireless. That's the enabled checkbox. Let's turn on the wireless so the users can connect. We have something called interface group. Right now it's set to management. That is the management network. I don't want users connecting to the SSID of wireless_LAN and jumping on the management network where they can access and configure the controller as well as the access points. Instead, we'll select the other network that's deployed, which is user_WLAN. This would be the user traffic, which is kept separate from the management traffic. That would be the equivalent of VLAN 5. We're not done yet. Let's go into the security tab and actually put a wireless password on that users will have to use in order to get on the network. We'll leave the default security of WPA and WPA2. We will leave WPA2 policy with AES. That's beautiful. But for the authentication key, I'm going to deselect 802.1x, and I want to use pre-shared key, which is PSK. I'll checkmark PSK, and it's going to ask me what password will you have the users type in. And for me, that's Cisco123 with a capital C. That's what the users will need to enter in order to gain access to my wireless. I'll click apply because we are done at this time for a basic wireless local area network. And then we're going to go back to the main home screen and verify that there is a wireless network, that users can see it, and that maybe a client has connected. So I'll click on home in the top right corner. And where before we had 0 wireless networks, now we have 1. Where there was 0 active clients, there is now 1. I can click on that active client and we can get more info about it. I can see the client's MAC address. The client has an IP address of 5.2, which is on the user network. Management network was 200. The user network is network 5.0. The client joined on the user network, and they joined on access point 1 using my WLAN profile of wireless_LAN on the wireless network name of wireless_LAN that the user saw. We have successful connectivity by deploying network settings and wireless settings on a controller and having the controller share it with the access point.
Okay, of course, there were hundreds of configurations that he did not share with you, and that's a good thing. You can learn that later in a different class. All right, so that video covered the majority of the configuration. Here, in this video, they're just showing you the topology and addressing scheme used for the topic that we're going through right now. Basically, we have a wireless LAN controller, and he showed you how on this wireless LAN controller we had multiple trunks. He did a good job explaining it. I don't think I need to show it. And then he went and configured the wireless LAN controller. I found this interface pretty easy to work with when I was going through the course. You just follow the directions. And I think ultimately we would follow the directions and have the steps written down when we were actually in a production environment. He showed you that we're going to, in this case, we're going to have a management LAN, and we're going to have which is the 200 network, and we are going to have a separate user data LAN, which was 5. He showed you the back of a Cisco wireless LAN controller and indicated that green was the one port that was being used. And then he talked about the fact that you could have multiple VLANs on this wireless LAN controller as you do with the switch, and that each AP can support multiple wireless LANs as well. Then he went through the configuration. He created a wireless LAN. He applied and enabled the wireless LAN. He selected the interface. He's added security to the interface. He verified the wireless LAN was operational. And then, of course, you will monitor the wireless LAN to ensure that the traffic flows properly and there aren't any security issues. And then he showed us that somebody had already logged in and that you could see the MAC address of the user. And here are the steps, but again, I don't feel like I really need to cover these. Well, maybe I should anyways. Let's go ahead and do it. So he created, in the wireless LAN controller, he created a wireless LAN. And remember, you have to turn it on. He named the wireless LAN, wireless_LAN, and he left it with ID 1. And then make sure you enable it on the general tab. He applied it. Don't forget to apply it. And then the interface that will carry the wireless LAN traffic must be selected, and he then added the security option. He enabled it using a pre-shared key, and that was the key would be the password. He then went to verify that it was operational, and he noted that there was one wireless LAN that has been enabled. And then there's one client that signed on, and then he showed you the MAC address of that client. That showed pretty easy stuff to do. You will configure a basic wireless LAN on a wireless LAN controller as packet tracer 13.2.7. Now configuring our security WPA2 enterprise on a wireless LAN using the wireless LAN controller. And there's a video to help us to understand the concepts. It is 13.3.1.
Hello everyone, we are here to do some management with our Cisco wireless LAN controller. This management is about SNMP and radius. Why do we use these? Well, let's start with SNMP. SNMP is simple network management protocol. We're going to configure our wireless LAN controller to use SNMP in order to forward log messages, known as SNMP traps, to PCA, which will be acting as an SNMP server. This allows us to have a centralized place, which is PCA here, in order to receive messages from network devices and what's happening, as well as pre-configured events. We'll configure that on the wireless LAN controller to send those messages to PCA. Setting up an SNMP server on PCA is outside of the scope of this lab. We have already configured it. It's running in the background. Besides SNMP, we'll also be deploying Radius. That's Remote Authentication Dial-In User Service. This allows us to use authentication and to verify credentials. How is this going to work? Well, instead of having every wireless client sharing the same pre-shared key of Cisco 123 as their wireless password, what if each wireless user had their own unique username password combo to gain access to the wireless? Well, they can. We're going to configure the wireless LAN controller to communicate with a radius server, which will be PCA. PCA will be the centralized location that we will store our users' usernames and password combinations. As our users try to connect to the wireless network on access point 1, they'll be asked for a username password combo. As they type it in, access point 1 will communicate with the wireless LAN controller, and the wireless LAN controller will verify those usernames and passwords are correct with the radius server. This is awesome. So let's deploy these settings on wireless LAN controller, and this wireless LAN controller is going to be referring to the 172.16.1.0 network where that radius server resides. The SNMP server is there as well, and the specific IP address of PCA ends with the .254. So let's configure our wireless LAN controller to communicate with both SNMP to send those SNMP trap messages, as well as radius to do successful authentication on behalf of our wireless clients. Let's get started. So we're here on our Cisco wireless LAN controller. We're on the main Splash homepage, and we're going to go into Advanced. Inside of Advanced, we're going to jump straight over to Management, and inside of Management, we'll be able to find the settings to deploy SNMP. On the left side, you can see a couple different management services that we can set up. We're going to focus on SNMP at this time. When I click on SNMP, we'll select Trap Receivers. We're going to inform our Cisco wireless LAN controller of the IP address of our SNMP server running on PCA. To do that, I'll click New. Then I can type in the community name that we will use, CCNA v7. Then I'll type in the IP address of PCA, which is running as the SNMP server. And now when I click Apply, this allows my wireless LAN controller to send SNMP trap messages over to PCA, which will then be collecting them. Now, besides SNMP, we'd also like to deploy some security authentication protocol here, and that's going to be radius. We want to use the radius protocol in order to have our users' username and password combos be sent over and verified on PCA running as a radius server. That'll be under security. We will find radius, and inside of radius, we will go to authentication. Now, we have the section for radius authentication servers, and it is blank down below. So let's click New, and we will create a new entry for a radius authentication server. Server IP address is again PCA. That's 172.16.1.254. The shared secret is a secret key that must match on both the radius server, PCA, and us for the wireless LAN controller. The shared secret allows the radius server to be able to successfully verify that the wireless LAN controller should be sending username and password combinations against its database on PCA. For that, it has to be the same on both sides, which is testing 1, 2, 3. And we type it in twice just to make sure it's correct. Down below, we can leave the default settings here for our radius authentication server. We've got the IP address, we've got the shared secret key, and I can click Apply. It is important for us to verify that the Cisco wireless LAN controller can successfully reach the radius server in order to send these requests of credentials against it. I can scroll over to the side, and here's a little blue drop down, and I can click on Ping, and this will send an ICMP message from the wireless LAN controller over to the server at 172.16.1.254, which is PCA. We've sent 3, we've received 3, we've got 100% success. So at this time, our wireless LAN controller can send SNMP trap messages over to the SNMP server on PCA, as well as our wireless LAN controller can send username, password combinations using radius from the wireless LAN controller over to PCA to verify users' credentials before they're allowed to join the wireless network.
Okay. And we are going to see those steps over the next few slides. So again, we set up PCA as the SMMP. The simple network management protocol. The MP is the important thing that will help you to remember that protocol. SNMP management protocol. Now we are going to trap or record messages, SNMP log messages from the wireless LAN controller. And then he walked through the steps, including going to SNMP and setting up a new trap receiver and giving it a name and telling the IP address of that PC1, what the PC that's going to be receiving the messages. And then we need to set up authentication security to be able to have that connection made, and then under shared secret, both the PC and, in this case, PC, and the wireless LAN controller must have the same shared secret key, and apply that, and then test it by clicking on that port at the end, at that button at the end that pinged the PC to ensure that the PC could receive those messages. The next thing we're going to cover is configuring a VLAN for a new wireless LAN, and it is 1335.
Hello, everyone. We are here to deploy a virtual interface on our wireless LAN controllers. But why are we doing it? Well, what it comes down to is every single wireless local area network that we deploy using our wireless LAN controller, those wireless local area networks need their own virtual interface. A virtual interface would be an interface VLAN. But first, let's take a quick peek at the physical view of our wireless LAN controller. We have 5 ports for data traffic, the blue one followed by the 4 yellow. Each of these physical ports can be configured to support multiple wireless local area networks. It would be done by us taking our virtual interfaces that we deploy, and we'd map that virtual interface to be used by physical ports. And these physical ports can even be bundled or aggregated to create larger high bandwidth links. So let's take a look at our topology again, and then we'll get started in the config. So in our topology, what you'll see is we're going to have VLAN 5. And VLAN 5 is going to be a data VLAN, which is going to be mapped to a wireless local area network that's in use on our wireless LAN controller. Then that VLAN 5 network will be able to be routed by our router R1, which is going to have IP address 192.168.5.1 on it. As users join the wireless network that's associated with interface VLAN 5, those users will be placed on the VLAN 5 network. So let's get started in deploying this. So it's time for us to configure our wireless LAN controller with a new interface VLAN so we can have a VLAN 5 network up and running. So to get started, I'm going to go into my advanced button here. And inside of advanced, we're going to go over to controller. And when I get into controller, we're going to go to the interfaces section. So when I click on interfaces, we'll get a list of all of the interfaces running inside of my wireless LAN controller. Right now, we're configuring the controller on the management interface at 200.254. I want to create a new virtual interface for VLAN 5 so I can have user data move through a VLAN 5 network with a new wireless local area network. So to get started, I'll scroll over to the right. I'm going to click on New for a new interface. It asks me for an interface name. I'm going to keep this simple. I'm going to call it VLAN 5 underscore user data. And it asks me for the VLAN ID number, which will be 5. When I click apply, we're not done. We get a lot of options that'll pop up. So now I need to fill in some information. One of the first things I need to set is the port number. For the port number, this is going to be the physical port on my wireless LAN controller. We're using port 1 out of our 5 ports. Also, it wants an IP address, and this is going to be the IP address of the wireless LAN controller on this network. If we go back to our topology, we'll see that we should have the 5.254 IP address on the wireless LAN controller, and the router will be using 192.168.5.1. So on the wireless LAN controller, I will put in the IP address of 192.168.5.254. That net mask or subnet mask is a /24, which is a class C. The gateway is going to be the router's IP address, which is the exit point for the VLAN 5 network. So I'll put in 5.1 for the router. I don't have IPv6 addressing info, but as clients do come in on the wireless network and join onto network 5, this network should have a DHCP server, and that'll be router R1. It's going to provide DHCP services for the local network. Now, a wireless LAN controller can be a DHCP server, but there's only a specific reason for that, and that's usually to give IP addresses to the access points themselves, and only the access points. That's for management purposes. So there's nothing else for me to configure on this screen. We are good to go to hit apply, and I'll do that in the top right corner. Do a little pop-up for a warning. We'll click OK, and our VLAN 5 user data interface is now deployed on our wireless LAN controller. And this is that virtual interface. So I'm not completely done yet because the virtual interface exists, but now I need to map it to a wireless local area network. So I'm going to go into my wireless LANs, and inside of here, I'll find my user data Wi-Fi. I'll click on that wireless, which is the number 2 ID. And inside of here, there's a drop-down for interface and interface group. Right now, this is putting users on the management network. But if I click that drop-down, now I can select that new interface VLAN 5 and have it mapped to the user data Wi-Fi. As my users join the user data Wi-Fi wireless network, they'll be put on the VLAN 5 network. And apply makes it happen.
All right. Remember, all of these videos can be found on the, all these videos can be found on itexamanswers.net. It's itexamanswers.net, and it has all these concepts with all the videos. All the same content that's on Cisco NetAcad is here on itexamanswers.net. And they also have the exam answers, but don't use those exam answers. That's not why I'm showing you this. It has all the videos in case these videos don't quite sound right when you're watching them in my recording of a recording. All right, so he did this. Basically, he configured VLAN 5 for user data on this trunk link between S1 and the wireless LAN controller. And it is up and up when he got to the end. He talked about how to configure it. He showed us the steps to go through, configuring the VLAN, setting the IP address and the port number for the wireless network, I mean the VLAN 5. And then he added additional information that would be handed out as devices come onto the wireless LAN controller on the wireless access point. They'll be handed out things like a DHCP server, and then he connected the two, ensuring that the users were on the user wireless, not the management wireless. All right, next thing we cover is DHCP Scope, which is 13.3.8. And 2.3, let's go backwards here. What if we do it this way? All of these videos, you know by now, are all inside of the content, so I can just go to 13.3 and then 8. Remember, this information is critical to understanding the concepts. My videos are just an overview of the material. You really need to go through all of the NetAcad content to truly understand and to prepare for that CCNA exam.
Hello, everyone. I hope you're ready. We are here to deploy a DHCP scope on the wireless LAN controller. DHCP? I thought that was on the router. Well, we're going to deploy a DHCP scope, which is very similar to a DHCP pool, We're going to do this on the wireless LAN controller. And we're going to do this because we want to provide management IP addressing to management devices using DHCP, all controlled from the WLC. Now, this is a specific use here. We're going to provide IP addressing to management devices. We're talking access points that are joining our wireless LAN controller, and we're talking possibly a management PC that would be used to configure the wireless LAN controller. So let's get started. Just a quick reminder here as we get started in configuring the wireless LAN controller, but we are going to be configuring a DHCP scope, not for providing hundreds of users IP addressing. We're creating a DHCP scope to provide dynamic addressing to management devices on the management network, which includes a management machine, as well as our lightweight access points that'll be joining with our controller. So let's get started. We're going to go into the advanced section first. When I click on advanced, we'll have our new screen come up. And inside of this area, we're going to go into controller. Within controller, on the left side, we're going to look for the internal DHCP server. And again, this is very similar to a DHCP pool on a router. DHCP scope looks just like a DHCP pool. I'll click on DHCP scope, and we'll see we're going to have an address pool, lease time, and some other info. Let's get started by clicking new, and you'll give ourselves a scope name, such as management_IPs. That's a beautiful name for management purposes. With the name of management IPs, I can click on that name I've created. It'll load a new screen for me to fill out all the information regarding my DHCP scope. We're going to begin with the pool start address, and this is going to be the first IP address that I'm going to have my DHCP service provide on this management subnet. That'll be 192.168.200.220. This is the first IP address I'd like to provide on this management network by using this DHCP scope. And the last IP address would be the pool end address. I'll make that 192.168.200.240. In all, I'll be providing up to 20 IP addresses using this management scope. It allows me to deploy up to 20 lightweight access points or a dozen and then some other IPs for management purposes. The network itself is 192.168.200.0, and the subnet mask for this management network is all 255s ending with the .0. The lease time we leave at the default. The default router is the exit point for the network. That is not us on 200.254. We're a controller. The exit point is going to be the router's IP address, which is router R1, which is 192.168.200.1. Our scope is good. We need to just enable this. So we'll change the status from disabled to enabled, and we can go ahead and click apply. Our scope is now created on the wireless LAN controller, and now we can verify it's ready to be allocated to a new wireless local area network.
Okay, and I think that was pretty clear, pretty easy, because we've already dealt with
Hello, everyone.
We've already dealt with setting up an IP pool, so it isn't that much different than that. And here we go. All right, good. He created a DHCP scope. It was pretty easy to do. He did it by going to new under internal DHCP server, DHCP scope, and then he just configured all of what we would normally consider the pool in an address, and then he enabled it to verify that it was working. Now we are going to configure a WPA2 enterprise security. It's 13.3.10. 13.3.10. Let's enable security.
Hello, everyone. It is time to hook a company employee to a company data network using wireless. So in this scenario, we've got a company employee on a laptop, and they're going to be connecting to a wireless network that we're about to build. This wireless network is going to use WPA2 with enterprise. What that means is we're going to go on the wireless LAN controller, configure a new wireless network to be deployed to our access point, And we're going to utilize enterprise with authentication. That employee is going to need a username and password combo to get on the wireless network. And our wireless LAN controller is going to take those credentials that are submitted by the user, and they're going to forward them over to PCA, which is running as our radius server, and it'll get a response back and either allow or disallow that company employee on the company network. So let's get started in configuring the wireless LAN controller. So here we are on the dashboard of our wireless LAN controller. We're going to start by clicking on Advanced. Inside of Advanced, we're going to go to our section of Wireless Local Area Networks, and we're going to create a new one. So we have the drop-down set to create new. We'll go ahead and click on Go. And we're going to name this. The profile will be company name. Our SSID, the wireless network name that our users will see, will also be company name. And then ID value, we can leave it at 2. I'll click Apply, and now we have a lot more settings to look at. We'll enable this wireless network, and we're going to make sure that the interface is using our company data network, which is our VLAN 5. That's where the data is. VLAN 1 is our management network. We're leaving that alone. We can leave the rest of these settings at their default, and now we go to security. Inside of security, we see that we're allowing WPA and WPA2, but down below, we have 802.1x set by default. This is what we're going to utilize and use this in order to have our devices that connect to the wireless be requested for username password authentication. But we need to have those requests forwarded somewhere, and that's going to be our tab for the AAA servers. When I click on AAA servers, you'll see that no servers are currently selected. In a previous video, we actually identified a radius server inside of our wireless LAN controller configuration. So in the server one dropdown, I can actually scroll down and I can select a previously identified radius server. The port of 1812 is set, as well as the IP address, and this is the IP of PCA, which is running as the radius server. We're not using any accounting feature, so we leave that at the default of none. At this time, I can now click Apply, and now the company name profile has been deployed on a wireless LAN controller, and this wireless network will be shared out to our access point. Let's do some verification. So let's go ahead and click back, and we should be able to see this wireless profile now created. And here you can see it. Wireless LAN ID is 2. Remember that. It's a type of wireless local area network. The profile name we created was company name, and the wireless LAN SSID, which is the wireless name the users will see, is company name. We have this thing enabled, and we're using WPA2 with 802.1x for our authentication. That authentication being requesting usernames and password combos as our users connect to the wireless. But let's verify that our wireless LAN controller can actually take a username and password combo that it will receive from a PC, forward it over to our radius server, and have the radius server respond back with a successful authentication message. To do that, we're going to the console port of our wireless LAN controller. So here we are on the console port of our Cisco wireless LAN controller, and we're going to use 2 different commands here in order to verify that our wireless LAN controller itself can take a username password combo, throw it against the radius server, and have the radius server respond back with a successful authentication message. So to get started, we're going to use the command test followed by AAA, and we're going to use radius. The username command followed by the username of Bob. Because you know what? One of our wireless clients might have a username of Bob. And followed with the command password. And Bob's password is probably hello. That's a nice combo. And then we're going to specify that wireless LAN ID. And this was that ID value we saw in the GUI, which was an ID of 2. And this was the profile company name with the wireless SSID, company name, and using WPA2 with our 802.1x authentication. So we're going to shoot this off to our radius server, and we should get a response back. And let's take a look at seeing that response. To see the response, we're going to use the command test AAA followed by show radius. And let's see what the server sent us back. Well, our server sent us back an authentication response result code success. We've successfully reached out to the radius server from our wireless LAN controller with the credentials of Bob hello, and the radius server says that user is good to connect. This is awesome. Enjoy WPA2 with Enterprise targeting a radius server on the wireless LAN controller.
Now, I liked the I liked the introduction of configuring a radius server in this chapter. I think we are ready for that. Remember, this allows for authentication and it AAA, and it is a critical element in allowing people to enter your network. So it's important to understand. He went ahead and created the new wireless LAN, and he named it company name, and he used ID 5. He then enabled the wireless LAN for VLAN 5 by clicking Enable under the General tab, and then VLAN 5 under the interface, and then he applied it, clicked OK, and then he left 802.1x enabled, and the rest of the security tabs as their default. He said that they configured the radius server earlier, but not in this class. Remember at the first video, he said that the configuring the radius server on the host PC was beyond the scope of this class. So he meant that previously, not in this class, but previously they did it so that it would be ready to go. So don't worry about that end. And then you can see and verify that the new wireless LAN is listed. And you can see that by clicking on the wireless LAN. You're going to do a packet tracer where you are going to configure WPA2 Enterprise on a wireless LAN on the wireless LAN controller. Should be fun. Our last section, 13.4, is troubleshooting wireless LAN issues. And there's several issues you could have. You could have network problems. They can be simple or complex, and they can result from a combination of hardware, software, and connectivity issues. Technicians must be able to analyze the problem and determine the cause of the error before they can resolve the network issue. This problem is called troubleshooting, which you've already done in this class. Troubleshooting any sort of network problem should follow a systematic approach. Common and effective troubleshooting methodology is based on scientific method and can be broken into 6 main steps shown in the table. It says that this is, by the way, this is the same troubleshooting technique that they taught you back in hardware in your A+ class. First, you identify the problem, you establish a theory, you test the theory to determine if it's the cause. Then you establish a plan to resolve or solve the problem. Then after you've implemented your plan, then you verify that it actually works and the equipment is back to normal. And then you document to ensure that the next time the problem happens, you have a plan already laid out. It also allows you to monitor things that happen on a regular basis, which could cause or could be caused by some other problem that you're having. So that's just basic troubleshooting, not anything specific to wireless LAN controllers or the chapter we're in. This is a really good way of just defining what troubleshooting is. Now, here's an example. If there's no connectivity and the wireless client is not connecting, check the following. Confirm the network configuration on the PC by using the ipconfig command. Confirm that the device can connect to a wireless network. Ping a known IP address. If needed, reload drivers as appropriate for the client and try a different wireless NIC. If the wireless NIC of the client is working, check the security mode and encryption settings on the client. Ensure they match. Ensure they match the server, wireless controller, whatever you're connecting to. If the PC is operational, but the wireless connection is performing poorly, check the following. Is the PC out of the planned coverage area, basically too far away from the wireless signal? Check the channel settings on the wireless client and check for interference with 2.4 gigahertz band. In other words, you've got your router on top of a microwave, or your computer, or your laptop. You're sitting on top of a microwave and it's cooking your lunch. That could cause a problem. Next, ensure that all the devices are actually in place. Consider a possible physical security issue. Is there power to all the devices, and are they powered on? Finally, inspect the link between cable devices looking for bad connectors or damage or missing cables. If the physical plant is in place, verify the wired LAN by pinging devices, including the AP. If connectivity still fails at this point, perhaps something is wrong with the AP or its configuration. When the user PC is eliminated as the source of the problem and the physical status of the devices is confirmed, begin investigating the performance of the AP. For example, check the power of the AP, make sure it's on and it's got the right type of power. What do you do when the network is slow? Well, to optimize and increase the bandwidth of an 802.11 dual band router and APs, either upgrade your wireless clients. If you're using 802.B, goodness, you need to upgrade that. Even G is getting out of date. N is not the newest, but a lot of people still run 802.11n devices. They can slow the entire wireless LAN. For the best net performance, all wireless devices should support the same highest acceptable standard. Hard to do if you have cutting edge like AX. I don't even know if they make laptops yet with wireless with 802.AX. I think that's just AC expanded. So let's talk AC. I'm not sure if my phone is even 802.11 AC. I'd have to check on that. There are several reasons for using a split for using a split the traffic approach. The 2.4 gigahertz band is may be suitable for basic internet traffic that is not time sensitive. The band may still be shared with nearby wireless LANs. The 5 gigahertz band is much less crowded than the 2.4 gigabit band, and it's ideal for streaming multimedia. The 5 gigabit band has more channels, therefore the channel chosen is likely to be interference-free. Now, continuing when we're talking about it being slow, by default, dual band routers and APs use the same network name on both the 2.4 gigabit band and the 5 gigabit band. It may be useful to segment the traffic. The simplest way to segment traffic is to rename one of the wireless networks. To improve the range of a wireless network, ensure the wireless router or AP location is free of obstructions such as furniture, fixtures, and tall appliances. These block the signal, which shortens the range of the wireless LAN. If the problem still does not solve the problem, then a Wi-Fi range extender or deploying a power line wireless technology may be used. Even walls can block the signal from one room to another, so it's not like you can remove all the walls in your house though. Updating the firmware. Most wireless routers and AP offer upgradable firmware that should be periodically verified. On a wireless LAN controller, there will most likely be an ability to upgrade the firmware on all APs that the wireless LAN controller controls. In the figure, the firmware image that will be used to upgrade all of the APs is downloaded. On the Cisco 3504 wireless controller, click Wireless Access Points Global Configuration, and then scroll to the bottom of the page for the access point image pre-downloaded section. Let me zoom in on that so you can see it a little bit better. So here it is pre-downloaded, right? You're going to do a packet tracer on troubleshooting wireless LAN issues, and you're going to do one on wireless LAN configuration. And that is the presentation, just a few minutes longer than I promised you it would be, but hopefully it was informative and interesting. Make sure you have great notes because there are so many different concepts covered in this chapter. They're not difficult, but you need to make sure you understand all of them. All right, so my name's Don LaFont, Professor Don. If you have any questions, please hang on if you're live with me, and I'll answer those questions in a moment. If you're watching it as a recording inside of NetAcad, please ask your questions inside of our help discussion forums. And if you're watching it out on YouTube, ask your questions down below in the comment section, and please rate and follow, subscribe, rate and subscribe to my podcast. That way you get to find out when I make new videos and release them. And you also help me, so I appreciate that. All right, thank you so much for coming to class, and I'll see you again in the next module, Module 14, which should be next if you're just watching my videos.